very important sum, and this is going to be very interesting. Let's see the sum. It says triangle ABE is congruent to triangle ACD. In the figure, we have two triangles to be congruent given to us, right? Triangle ABE, which I have highlighted there, and the other one is triangle ACD. These two triangles are congruent, and we need to show that triangle ADE, right? Triangle ADE is similar to triangle ABC. That means that smaller triangle and this bigger triangle, they are similar to each other. The only information which we have is that triangle AB is congruent to triangle ACD. So that given information is something which you are going to use, this one. So we write it here. A triangle AB is congruent to triangle ACD. What is the reason for this? We know the reason is given. We have it here. Now from this we need to use information so as to prove those two triangles similar, which we have to prove, right? Now first, we know when two triangles are congruent to each other. What do we know about their corresponding sides? We know that they are equal, right? So that means if I consider AB, for AB the corresponding side is nothing but, we can see there itself, it is nothing but AC. So we can say that AB is equal to AC. This is what we can get here. And let's say that is my statement number 1, and that is CPCT, that is corresponding parts of congruent triangles. We've taken this. Let's consider another one, right? But the question is, why did we take AB and AC? We took AB and AC. Why? Because it is nothing but they belong to triangle ABC, and that is what we want in the true proof. One of the triangles there, that is triangle ABC. Now the next one. Let's consider something else. Now which one are we going to take? Let's say we take AE, and for AE the corresponding side is going to be AD. That means we are saying AE is equal to AD, and that is what we write there, right? So the next question is, why did we take AD and AE? We know why. Yes, because that is the next triangle which we want, that is triangle ADE, and they are the sides of those two triangles. That means now we have AD is equal to AE, right? This is what we have arranged it, and this will be our statement number 2. Reason would be CPCT, that is corresponding parts of congruent triangles. But the question is, here we need to prove these two triangles to be similar. Now that is very important. If we have the ratios of this corresponding sides equal, then we can say the triangles are similar. That means for similarity, we require the ratios. So now let's write it in the form of ratios. So now we'll write ratio. So for the ratio, we need to divide, right? So divide equation 2 by 1. So we would get now, that is AD upon AE, right? AD upon AB is equal to AE, that is this from the second one, is equal to, rather, AE upon AC. That is what we got. So we got AD upon AB is equal to AE upon AC, and this will be our statement number 3. Reason would be dividing equation 2 by 1. Right? So now have we got the ratios equal? Yes. So let's consider the two triangles now. So we are writing triangle ADE and triangle ABC. In these two triangles, we have those two ratios. That is AD upon AB is equal to AE upon AC. And the reason for that is nothing but from 3. We got this. So we got two ratios to be equal. Ratios of the corresponding sides. Two ratios equal. Then we have learnt a criteria wherein it is SAS criteria. So we require an angle. But remember, that angle has to be the included angles. Do we have anything there? Yes, that is angle A. Why? It is an included angle, and we know it's a common angle for both the triangles. So we consider that now. So we write angle A is equal to angle A, and we know the reason for that is nothing but it is a common angle. We write that now. So we got this common angle. So now we can say that both the triangles are similar, but by which criterion? We know they are similar to each other by SAS criterion, side angle side criterion, right? And that is what we write there. So we write there that both the triangles, that is triangle ADE, is similar to triangle ABC by SAS similarity criterion, and we get the sum. It's easy.